In this part 2 discussion on unit number 5 of physics for civil engineering paper, we are going to discuss about the earthquake, one of the most dangerous hazards that mankind has ever encountered. So before understanding the basics of earthquake, we must know some of the basics related to the interior of the earth. So it is very well known that the earth has many layers inside it, and beyond some layer we have a presence of large amount of huge rocks, and all these huge rocks are bound to have some fractured portion in them, which is termed as fault. And this earthquake phenomenon is something which is got to do with this fault. Let's see what earthquake is all about. So earthquake is an event where you are going to have a sudden slip on the fault of the earth. As I was mentioning, fault is the fractured portion that exists in the rock which are present up below the earth surface. And exactly at that fractured portion, when internal forces which are available inside the interior of the earth acts on them on the rocks, then huge amount of stress will be applied on rocks, and due to this stress which has been created because of the large amount of force, then exactly at those fault, namely the fractured portion, we are bound to have some sudden slip over there, and this sudden slip event is what called as earthquake, and it will be accompanied with ground shaking, which we literally experience above the earth surface. And also it is accompanied with the emission of large number of seismic radiations, where we are going to see about this term seismic radiation or seismic energy in detail in a short while. Okay, and what are the causes for the earthquake to happen? The first and foremost very common cause is, as I was mentioning, the slip that happens in the fault inside the earth surface. And the other possible causes for the earthquake event to happen are volcanic activity and then sudden stress that changes the inside earth interior, some kind of sudden stress or force that acts on it. These are some of the probable reasons for the earthquakes. And as we are mentioning, earthquake mostly happen at the fractured region available inside the earth, which is technically called as fault. And there are three types of faults identified by their movement due to the slip. Okay, the first one is strike slip. Strike slip is the one where two rocks are going to get slipped in an adjacent manner, okay, sidewise. And the other one, normal slip, is the one where you are going to have the slip of one of the rock with respect to the other rock below the normal landscape position. And the third one is reverse fault, which refers to a condition where one of the rock with respect to the other will be getting displaced or slipped above the landscape position. Okay, so these are the three types of fault which has been identified because of their movement. And there are some basic terms related to the earthquake. The first important term is focus point. So what is focus point? Focus point is the point in the vault where exactly the slip will begin, or it is the point where the earthquake originate. Okay, and we also have another technical term called epicenter, where epicenter is the distance between the focal point, that is focus point of earthquake, and perpendicular distance to the landscape point. So this difference is what called as focal epicenter. Okay, and when you or in simplest note, when you are going to draw a line from focus point towards the earth surface, then that line will meet the earth surface at one point, and that point will be referred as epicenter point. And as it is depicted in this picture, you have a circular image here, right? A lot of circles are available, and these circles are representing the propagation of seismic waves, which we are going to discuss in detail in a later stages of our presentation. Now, what are the impact of earthquake? When earthquake happen, what immediately happens? The first thing that is going to happen is the emission of seismic energy. And when seismic energy is emitted in the form of waves, it is going to result in some secondary consequences. What are those secondary consequences? The most commonly available consequence is ground shaking, which is clearly shown in the first picture. So ground is going to shake, as a result, a lot of damage will be happening to the landscape. And the second one is landslide, which usually happens in the hilly areas, right? And the third probable thing is tsunami, which happens whenever the earthquake takes place deep inside the ocean. When earthquake or the ground shaking is happening in deep inside the ocean, then it will lead to the rise of water to a very high level, which we technically call it as the tsunami. And the third one is liquefaction of ground, where the solid ground will lose its stability and it is going to become a semi-solid one. And as a result, lot of buildings and other things may even get washed away whenever this particular event, liquefaction of ground, happens. Okay, these are the consequences or effects of earthquake which will happen. The important term related to the earthquake is seismology. Seismology is the scientific study of earthquakes, and in particular it is the scientific study of seismic waves, which is usually produced during all the earthquake events. And this entire theory was once developed by a scientist called John Winthrop from America. And even he was termed as the founder of seismology. So what are seismic waves? Let's shortly give a very simplest note. Seismic waves are the waves that travels through the earth interior because of earthquake. And mostly tectonic earthquake is referring to the sudden slip that occurs in the fault. The other possible events are large landslides and then large man-made explosions. In all these events, inside the earth's surface, some kind of wave is going to propagate inside them, and we call that waves as the seismic waves. In other ways, we can also see the seismic waves as seismic energy. Okay, and you have an instrument called seismograph or seismometer, which is used to detect and record the earthquakes. And what are the practical uses of seismology? The first thing, it gives us a clear data of the kind of thing, the kind of events or consequences that will happen inside the interior whenever we conduct a nuclear test. Because we know that when nuclear tests happen, then large and huge amount of energy is going to be related to it. And that happens, then we need to collect some seismic data, that is the seismic waves data and energy data, which can be done by a clear understanding of seismology. And also we can have a clear idea on what is the speed exactly at which the seismic waves are traveling inside the earth's surface. So these are the practical applications of seismology. And you also, we have heard these familiar terms like intensity and magnitude of earthquake. Let's say what is intensity of earthquake and magnitude of earthquake. So first one is intensity of earthquake. So it is the qualitative measure of damages which is caused because of the occurrence of earthquake at a particular location. So whenever the earthquake is happening at a particular place, then that place is going to have some amount of damage, and a qualitative measure of that damage is what called as intensity of an earthquake. On the other hand, magnitude of earthquake is simply the measure of its strength in terms of seismic energy involved in it. Okay, so simply magnitude is a measure of the earthquake size, and intensity is an indicator of the severity of ground shaking at a given location. Simply it is like cause and effect. So here the cause is going to be magnitude. So at what high scale or low scale the energy is going to be involved. So related to that, we are going to have the damage happening. So damage is the effect. And here the effect will be intensity of earthquake. So magnitude and intensity is something like cause and effect pattern or a kind of scenario. So magnitude of an earthquake is usually measured in a very commonly known scale which is called as Richter scale. And this Richter scale was developed by a scientist called Charles F. Richter of California Institute of Technology. And based on the values of Richter scale, we can have a clear understanding of how dangerous a earthquake was, whether it was mild or it was very heavy, causing high intensity values, which means that high damages or low damages. For a moderate earthquake, the value of magnitude is usually in the order of 5.3. Whereas when an earthquake is said to be very strong, then as far as Richter scale is concerned, the magnitude value will be 6.3 and above. So all the earthquake where the Richter scale has recorded a value of 6.3 and above, they will be termed as strong earthquake where the impact is also going to be high. In other words, simply intensity of earthquake is also going to be high. Okay. Now, let's go into the seismic waves in detail. So, seismic waves are the low frequency waves that travel inside the Earth's surface whenever the earthquake event is happening. And it is the waves which is usually recorded using the instruments called seismographs or seismometer. There are two types of seismic waves. One is body wave and the other one is surface wave. Let's explore them in detail one by one. First, let us begin with the body waves. So what are body waves? So body waves are the waves which travel through the earth, which is called as body wave, which means that it is not the wave which is traveling in the upper surface of the earth. Instead, it is the wave which is traveling deep inside the earth portion. So earthனுடைய interiorல travel ஆகக்கூடிய that ray is what we are calling it as the body waves. To put it very simple, the wave which propagate through the body of earth is called as body waves. And there are two types of body waves. The number one is primary wave, which is referred as P wave. And it is a scenario where the propagation of prime wave will be in such a way that it is going to be parallel to particle motion. Okay. So the pattern in which the wave travel is parallel to the motion of the particle. Such waves are called as primary waves. And then comes the secondary wave, where the propagation of wave is going to be happening in the horizontal way, whereas the vibration of particle, because of the wave the particle will be vibrating and the particle motion will be perpendicular to the propagation of wave. Such waves are called as secondary waves. And then comes surface waves. So what are surface waves? These are the seismic waves which travel along the earth's surface. So types of surface waves, again there are two types of surface waves. One is love wave and the other one is Rayleigh waves. First, let's discuss about the love waves. The love wave is the one, let's assume that you are having the wave propagation in the x-axis, and in that node here the ground shaking is going to happen in a normal direction with respect to the wave propagation. Okay, so such waves are called as love wave, and it is followed by the Rayleigh wave. So Rayleigh wave is the one where the ground shaking will be happening in the pattern of just like how the waves in the ocean are rolling out. So that's such kind of scenario will happen inside the earth's surface. On that note, the seismic waves will be termed as Rayleigh's wave. And it is very important to analyze the seismic energy and seismic waves in order to have a clear understanding of the impact of hazard which can be created because of the earthquake. On that note, the analysis which discusses the seismic hazard is called as seismic hazard analysis, where we are going to have an estimation of measure of the strong earthquake expected to occur at a selected site, whether a selected site is having the probability of occurrence of earthquake or not. These kind of analysis we can easily do based on the seismic hazard analysis. Why it is important to analyze this seismic hazard? Because once we are able to do that, then we can prepare ourselves to encounter the earthquake event that can happen at any type of locations. So throughout the world, we definitely have a scenario where some portions are highly prone to earthquake and some other portions or some other region in the world are less prone to earthquakes. So in the portion or in the regions where the earthquakes are bound to happen at a higher rate, then definitely right from the building structure, right from the construction of building itself, you need to take lot of efforts in order to make sure that the buildings and then dams and then high rise buildings, long span bridges, they are all designed in such a way to overcome the earthquake event. Okay, so to do that, it is a highly recommended to do a proper seismic hazard analysis. Only then we are able to do all these things successfully. And there are two types of seismic hazard analysis. The first one is deterministic hazard analysis and the second one is probabilistic hazard analysis. Let's see one by one. So the first one is deterministic seismic hazard assessment or analysis, which is usually undertaken to calculate the probability of ground motion for a single scenario earthquake. So based on the history data, we are going to focus on a single scenario earthquake, and based on that, lot of analysis will be done, and based on that analysis, we are going to come to a lot of interpretations. How much uh, strong a earthquake will be if it happens at a given particular portion, region. That idea we can clearly have by using this deterministic seismic hazard assessment. And there are mainly three steps involved in it. The first one is we need to identify all the possible sources which can lead to the earthquake event at a particular site using the historic data. So a site will be there, and near the site you may have three sources. First one, say the normal fault which is present inside the earth. The second one may be there may be a volcano which is present nearby, and third one there may be a place where the nuclear test will be happening. So these kind of things should be arrived based on the historical data, and based on that the locations will be marked as M1, M2 and then M3. And then choosing a fixed distance and fixed magnitude, we need to place it on the closest position to the site on each source. After that, we need to estimate the ground motions of earthquake in order to determine the ground motions at the site in terms of various analysis patterns like PGA and other types of other measures. So by doing this, we can have a clear understanding of the seismic hazard analysis. And the next one is probabilistic seismic hazard assessment. So here it calculates the probability of exceeding all levels of ground shaking at a certain location. So not only a single place scenario, here we are going to consider the all levels of ground shaking at a certain locations. Okay, and it consists of these following steps. So first one, collect data based on the tectonics and geology, how much the places will be prone to have the earthquake event or not, and then compile an earthquake catalog for the region. So we need to define seismic sources zones properly, and then we need to determine the magnitude frequency relationships, and finally we can calculate the probability of each level of acceleration, and ultimately the hazard curves and maps which will be obtained will give us a clear understanding on the seismic hazard analysis. So in this earthquake session, we started with the basic introduction about the earthquake, and then followed by that we also got exposed to the terms like epicenter and then focus, etc. And then we also discussed about the very important term which is seismic energy and then seismic waves, the types of seismic waves involved. And finally we also discussed about the seismic hazard analysis, where we have been discussing about two things. One is deterministic seismic hazard analysis and the other one is probabilistic seismic hazard analysis. Thank you.